Welcome back. Today we are going to take a look at logic and truth tables. So first of all, we're going to go over the symbols and their meaning, and then I'm going to go a little bit into how I solve these. So this means not. So we put this in front of a value. So we've got P and not P. If P was true, then not P would be false. In this column, we're going to assign a 1 to a true statement and a 0 to a false. And then we're going to use math in a traditional sense to solve truth tables instead of making sentences. So if we were going to look at this, if we assign P a 1, so that's still true. And then this one would be 1 minus P, and that would be 0, which represents false. So this does work out. Moving on then, we have conjunction. So you're going to see one of these two symbols, and it means and. So P and Q is equal to the minimum value of PQ. So let's think this through. If they asked you to return a true value if both P and Q happened, well, that means to get a value, you would have to have them both have a true, which is both equal to 1. And then the minimum value of that would be the 1. Whereas if only one happened and not the other, one of them would have a 0. So if you took the minimum value, you would receive the 0, and that would return a false for the statement. So this does work as well. If we go to disjunction, which is either or both, for this we take the max value. So we can also think of this as an or statement. So if we want P or Q, then we could just take the max of either one. So if P happened and it got a true and Q did not and it got a false, that'd be the same thing as 1 and 0. But that's okay, because either or happening makes this a true statement, and the max value of 1 and 0 is 1. This is exclusive disjunction. So if this is or, but including if they both happen, then this is or, but only if or happens. So this is equal to 1 if P does not equal Q. So remember, we were doing this. So if P and Q happened in disjunction, well, that max value, that'd still return a 1. But if we were talking about or only, so it can't be and, then 1 equaling 1, well, that would not satisfy this condition, and it would be a 0 to be returned. For conditional, this is an if-then statement. So if P, then Q, for that to equal 1, then P must be less than or equal to Q. So let's think about that one for a moment. If P was greater than Q, so if we had a 1 here and a 0 here, that would mean that P happened without Q. That's not possible with this condition. So we have this P is less than or equal to Q to satisfy that. So P cannot happen without Q happening. If we do have a less value than, or if P is less than Q, then it's going to return a 0 or a false for this statement. Lastly, we have biconditional, and this is the if and only if. It can also be written IFF. And that is equal to 1 if P equals Q. So for P to happen, Q must happen. So they would have to be equal to each other, right? True happens, then true must happen for the other to be true. Then 1 must be equal to 1. So let's go to our first example then. Actually, let's take a look at this formula first. So the formula for how many rows you need to add underneath your, or into your table is 2 to the n, where n is the number of arbitrary input variables. So if we go to our example, These, we're just entering in values, right? Normally we'd be entering in like true and false, but we're going to use ones and zeros. These not P, not Q, these are calculated off of these two. So these are not arbitrary. They're calculated values. And this is also calculated off of the rest of the table. So only values that are not calculated are included. So 2 to the 2 is going to be 4, so we add 4 rows. So we put 1, 1, 0, 0 in P, then we alternate values here. And then remember that not P is the same thing as saying 1 minus P, so 0, 0, 1, 1. And we do the same thing with Q. Okay, so we're looking at not P and not Q. So we're looking at these columns, or rather not Q, not P. And this is how it would be written in words. So when you guys have been traditionally taught how to do this, I imagine your teacher taught you to write out or think about this as a real world occurrence. That takes a lot of time, and it can get kind of fuzzy what some sentences actually mean in the end. So even if you were or are comfortable with that method, give these a try because they'll end up being much, much faster. So if we have an if-then statement, remember that we need it to be less than or equal. So not Q must be less than or equal to not P. That is true here. 0 is less than or equal to 0. It is not true here. 1 is greater than 0. That is true here. And that is true here. So let's enter this into our online calculator and see if they agree with our conclusion. They come up with true, false, true, true, and we came up with 1, 0, 1, 1, meaning the exact same thing. And the website is right up here if you want to try out your own. Alright, so moving on to example 2 then. Again, these are all calculated values, so we're not going to include them in our formula to solve for how many rows. We're going to get 2 to the n, so that'd be 2 to the 2, which is 4. So 1, 1, 0, 0. Alternate ones and zeros. Calculate P, or not P and not Q off of P and Q. Okay, and again we're looking at the not columns. So this means not Q if and only if not P. So if we recall our if and only if, that's going to be when these are equal to each other. So that would be 1, 0, 0, 1. And you can see how fast that was. So that was a better example of how quickly we could actually get this done by not thinking about it in sentences, because I didn't have to explain in between. You can really, you can blast through tables that are, 15 rows long in a couple seconds using these. So let's see if we were correct. We had 1, 0, 1, 1. True, false, false, true. So this works. Let's go on to our third example. So we have 3 arbitrary values now, and then we'll get rid of this for now. Oops. Okay. So we have 3 calculated values, so that's going to be 2 to the third. So 1, 1, 1, 1, 0, 0, 0, 0. 2 to the third is 8. So 1, 1, 0, 0, 1, 1, 0, 0. 1, 0, 1, 0, 1, 0, 1, 0. So I'm hoping that you've started to recognize this pattern. The first column is going to be 50-50. And then whatever that one is, you're going to divide it by 2. So instead of having 4 ones in a row, you're going to have 2, then you're going to have 2 zeros, 2 ones, 2 zeros. And again, you're going to do that with the next column over. This is half the number of ones in a row, so 2 divided by 2 is going to be 1. Then you're going to go and repeat that pattern. So just continue that up if you have more than 3. I haven't heard of many instances of that happening in the practice, but just so you understand how to make this pattern quickly. Okay, so we have P and Q or R. And this is not the exclusive or, this is the either or both. So make sure you recall that. So let's write this out, what we're trying to say here. We have an AND statement. So we're going to take the minimum value of P and the max value of QR. So right, we can just break this down into basically 2 different problems. Once we have this value, we can plug it in and find the min of P in that value. So if we want to do that, personally, I would create a new column. And calculate it out here. So the max, or the OR statement, the disjunction, is going to be Q and R, so the max value there is 1, 1, 1, 0, 1, 1, 1, 0. And now we're looking at the minimum value of P and the column we just calculated. So let's take the minimum values of those 2 columns then. 1, 1, 1, 0, 0, 0, 0, 0. And let's check our work. One, 1, 1, so true, 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 and then 5 falses. That's exactly what we got. So again, very quick. In my opinion, a lot less chance for error. But like I said, if you really want to start thinking about this as real-world sentences and going through this and trying to figure it out that way, because that's what you're most comfortable with, then that's fine too. And that should conclude it for this video.